Hi everybody, let's start this section by taking a look back at left and right hand sums and really focusing on a specific way to think about what we're doing. So let's say we're looking for L sub 3 and R sub 3 and we have an interval that looks something like this, A to B. So for left hand sum, we're going to split this into 3 subintervals. Hold on, that looks a little bit crooked. And similarly here. Okay, and for left-hand sum, we're going to start on the far left, and we're going to head up, and that's going to determine the height of our first rectangle. And then from the far left of our second-hand rectangle, we get its height. And from the far left of our third rectangle, we get its height. So we're looking at this as approximating the area under the curve, and that's absolutely what it is. But what I really want to focus on here is another way to think about this is we're taking this stretch of the curve right here, and we're trying to approximate that shape using segments of simpler curves. So in this case, it's these constant functions. So this flat top here, this flat top here, and this flat top there. We could look at it even as we're making this discontinuous function that goes along the top, and we're using it to say this is pretty close to what's happening on the function. Not perfect, but they're much simpler functions and they're doing a decent job of following the shape of that curve. And same idea for R sub 3. We're going to determine our heights now on the right hand side. There, and right hand side, something like that. And this is just another way to look at it using still constant functions, but they're just a little bit different. So this is the shape of our curve going along, and we could say one way to look at this is that what we're really trying to do is approximate the shape of the curve with these constant pieces. So we'll have one going from here to here, and then from here to here, and then from here to here. And it doesn't really matter where you put closed or open circles, but it's basically using piecewise constant functions to approximate the shape of this curve. So that's this bit right here, pieces of constant function. And we're going to use that to kind of motivate what we do next. But I do also want to talk a little bit about error while we're looking at this, because that'll be interesting for some of the methods we use after this. So notice that whether, and we've talked about this, whether we're getting an over or an underestimate for left and right would depend on whether the function is increasing or decreasing. So let's look down below here and we'll say, okay, so if this is my curve going along, the right-hand sum is the top box. So this right here is the error associated with the right-hand sum. And in this case, it's an overestimate. And then this little piece down here is the error associated with a left-hand sum. So the left-hand sum, that would be the top of the box, and we're missing all of this stuff right here. So this is the area associated with left, and basically that error is showing us that we have an underestimate. So that's stuff that we missed using the rectangle for left. When we look here, we notice, I hope, that so still this is the top one is the right hand sum rectangle, and the bottom, this chunk right here, is the left hand sum rectangle. So the extra stuff, oh, sorry, that should be an L. The extra stuff, this darker aqua color that I've labeled E sub R, that's the stuff that the right hand rectangle caught that wasn't actually under the curve. So again, that's an overestimate. And then the left-hand rectangle all falls below the curve. So this light teal stuff is the stuff that we didn't catch with our rectangle that actually is under the curve. So again, we're under. And then in this last one, here's our curve coming along. This time, our left-hand rectangle, the top of it is up here, so they've kind of reversed on us. And our right-hand rectangle is this bottom chunk right here. So now this light aqua chunk is above the curve, and that is the area that our left-hand rectangle captured, and our right-hand rectangle, our left-hand rectangle captured and our curve did not. So that's the amount by which we overestimated. And then the darker color, that's the stuff that our right-hand rectangle did not catch, but our curve did. So that's the underestimate. So we could look at more examples, but I'm hoping you can see there that whether the right-hand sum and left-hand sum overestimate or underestimate entirely depends on whether the function is increasing or decreasing. And also, to get into it a little more, this pair right here, the first two, I hope you can see there that we got much bigger over and underestimates in that second picture. And the reason is because the curve is steeper. So if your first derivative is positive or negative, that will switch which one is an over and which one is an underestimate. And if your first derivative has bigger magnitude values versus close to zero values, that will determine how big your over or underestimate are. And I think basically takeaway here is that the error associated with left and right hand sums is related to f prime. So f prime is the thing that's determining those errors. Okay, thanks for watching.